Picture this. What if, right this very second, somewhere out there in an endless cosmos, there is another version of you sitting exactly where you are, watching this exact same explainer? Mind-blowing, right?
Well, what if there's a universe where that giant asteroid totally missed Earth and dinosaurs are still running the show? Or, hey, maybe one where the Earth never even formed at all? Or, and this one really messes with my head, what if there's a universe where time actually flows backward? I know, it sounds like pure science fiction. But surprisingly enough, some of the most brilliant minds in modern physics are telling us this could actually be real.
Welcome to The Explainer. Today, we are absolutely diving headfirst into one of the most mind-bending mysteries in all of cosmology. We're talking about the very real possibility that our vast, massive universe is actually just one tiny little bubble floating in a practically infinite multiverse. We're going to explore the major scientific ideas driving this theory, the harsh criticisms against it, and whether humanity could ever, actually prove that these other universes exist.
So let's get right to it. Here is our roadmap for today. First, we'll start by expanding our cosmic perspective. Then we'll break down the four main types of multiverses. After that, we're diving into string theory and extra dimensions, followed by a look at the search for actual evidence. Then we'll weigh science versus science fiction, and finally wrap things up with the Anthropic Principle.
All right, Section 1. Expanding our cosmic perspective, from the universe to the multiverse. To genuinely wrap our heads around the multiverse, we really need to set a baseline first.
Just think for a second about everything inside our own universe. We're talking hundreds of billions of galaxies, trillions of stars, countless planets, dark matter, space, time, literally every single atom you've ever interacted with. For centuries, we logically, and maybe a bit arrogantly, believed this massive inventory was the whole shebang, everything that existed. But what if it's not? What if our universe just isn't the whole story?
Now, here is a major misconception we need to clear up right away. The multiverse isn't just one rogue, crazy theory. It's actually a collection of different scientific hypotheses, all suggesting that our universe is just one among countless others. And these other universes, they could have totally different laws of physics, completely different dimensions, or entirely different histories. And listen, scientists didn't just invent these ideas out of thin air because they sound cool for a movie. Actually, scratch that, they do sound cool. But these hypotheses emerged naturally. They are mathematically necessary byproducts that popped up when physicists were trying to solve some incredibly difficult problems, like figuring out why the Big Bang happened in the first place, or why the constants of nature are just so perfectly balanced for us to exist.
Okay, moving on to Section 2, the four multiverse types, escalating strangeness. Let's actually categorize the distinct flavors of multiverses proposed by science. And fair warning here, they get progressively weirder as we go.
First up is Type 1, infinite space. Imagine that our universe just extends forever. If space truly goes on forever, well, matter has to eventually repeat itself. Why? Because there are only so many ways you can possibly arrange a finite set of atoms. It's like shuffling a deck of cards for eternity. Eventually, you get the exact same order again. So, basic probability dictates that somewhere unimaginably far away, there is literally another Earth, another Milky Way, and another you, simply because in an infinite space, every possible arrangement of matter absolutely has to happen again.
Next, we have Type 2, bubble universes. So during a tiny fraction of a second right after the Big Bang, a period called cosmic inflation, space expanded way faster than the speed of light. Many physicists believe this inflation never actually stopped everywhere. Instead, it's constantly creating new, disconnected universes. Think of it expanding like bubbles in a pot of heavily boiling water. Each one of those bubbles becomes an entirely separate universe, and they could each have completely different physical constants. Our entire massive universe, it could just be one little bubble among infinitely many.
Then we hit Type 3, quantum many worlds. And this is where things get truly strange. Quantum physics suggests that whenever an event has multiple possible outcomes, reality literally splits. So instead of just one outcome happening and the others vanishing, every single possible outcome occurs in its own newly created universe. Did you choose to drink coffee instead of tea this morning? Well, an entire parallel universe just branched off where the other you chose tea. Every single possibility is realized somewhere.
And finally, the most extreme proposal of them all, Type 4, mathematical universes. This one suggests that mathematics isn't just some abstract tool we use to describe reality, it actually is reality. If a universe with completely different math, dimensions, or laws is mathematically consistent on paper, this theory argues it must physically exist somewhere. It really pushes the very limits of human comprehension, suggesting that literally every mathematical abstraction becomes a literal physical reality out there. So, just to quickly recap this crazy escalation. Type 1 gives us repeating matter simply through infinite space. Type 2 gives us disconnected bubbles formed by cosmic inflation. Type 3 branches reality over and over again through quantum physics. And Type 4 manifests all mathematically consistent concepts as literal physical reality. It's an incredible ladder of escalating cosmic strangeness, but it brilliantly helps keep all these massive concepts organized. Let's move to Section 3, String Theory and Extra Dimensions. The mechanics of reality. So what exactly is the physical engine driving some of these wild ideas?
Enter string theory. This is a leading candidate for a theory of everything, but to make its incredibly complex math work, it requires 10 or even 11 dimensions. Yeah, 10 or 11. It suggests that instead of tiny particles, everything is actually made of infinitesimally small, vibrating strings. Under this theory, our entire universe might just exist on a higher dimensional membrane, or what physicists call a brane. Think of our universe like a single slice of bread sitting inside a much larger cosmic loaf. Some physicists theorize that if two of these dimensional slices happen to bump into each other and collide, boom, it could spark the massive explosion we call the Big Bang.
All right, Section 4, Searching for Evidence, the hunt in the cosmos. We have talked a lot about mind-bending math and incredible theories, but let's get grounded for a second. Is there any actual hard proof out there? Right now, we have to be completely impartial and state that no, there is no direct proof yet. But scientists are actively hunting for clues. They're looking for strange patterns. Think of them almost like bruises in the cosmic microwave background radiation. These could be literal scars from where another universe bumped into ours. They're also searching for unexpected gravitational pulls coming from neighboring universes, specific signatures left over from cosmic inflation, and testable predictions coming out of string theory. So, while nothing is confirmed just yet, the hunt is very much ongoing.
Which brings us to Section 5, Science or Science Fiction, the limits of observation. Let's apply a quick reality check here. Will we ever be able to pack our bags and actually visit these other worlds?
Now, pop culture and sci-fi movies absolutely love the idea of multiverse hopping. Traveling via wormholes, quantum tunneling, or stepping through some magical portal. But the scientific reality is, well, it's incredibly sobering. Modern physics dictates that most of these proposed universes are fundamentally, permanently disconnected from ours. That means absolutely no light can cross the gap. And if there's no light, there are no signals, no travel, and absolutely no communication. We are entirely isolated, meaning these other universes may forever remain completely beyond our observation.
And that leads perfectly into Section 6, the Anthropic Principle, finding our place. Because if we can't see them, and we can absolutely never visit them, why does this matter to our existence at all?
There is a really beautiful analogy for this. Our universe may be only one page in an infinite cosmic library. This perfectly captures what's called the Anthropic Principle. Think about it for a second. Why is our universe so perfectly fine-tuned for life to exist? Well, if millions of other dead universes exist out there, ones with no gravity, no atoms, or just impossible chemistry, it makes logical sense that we find ourselves in the rare, life-friendly one. Because, simply put, if we weren't in the lucky universe, we just wouldn't be here to ask the question in the first place.
But, as you might guess, this brings us to a massive, ongoing scientific debate. Deep skepticism remains among a lot of very smart scientists. The whole foundation of the scientific method relies on making testable predictions. So if these other universes are forever beyond our observation, if they can't be measured, and if they can't be interacted with, can the multiverse truly be called science? Or is it really just fascinating philosophy disguised as physics? This remains one of the heaviest, most hotly contested debates in modern cosmology.
The multiverse challenges our very definition of reality. Perhaps future breakthroughs in particle physics, or maybe vastly improved gravitational wave detectors, will finally pierce that veil and point to what lies beyond our universe. Or, it might just remain an eternal mystery. So I want you to ask yourself, is the greatest mystery whether other universes exist, or whether humanity is even capable of detecting them? Thank you so much for joining me on this explainer. Stay curious and keep questioning the cosmos.